let's talk about the chain rule. So recall that the chain rule is a rule for differentiating the composition of two or more functions. And so it's a shortcut for determining the derivative of a combination of functions, in particular the combination of composition. Okay? And so I've put a couple of examples here to show you the rule for the chain rule. That is, if we have h of x, if it's defined as a composition of two functions where it's f composed with g, that is, f's input is replaced by g's output. Okay? Remember that the input of the function is just the stuff that we're plugging into the function. Okay, that's the variable. The variable of f is g, and the variable of g is x. And so if I want to take the derivative of h with respect to x, which is the variable of the g function, I have to go through f, g, and then finally go through x. Okay? So because I have a chain of functions here, f to g to x, I have to have a chain of derivatives when I'm finding the derivative of this composition of functions. Okay? Remember that the derivative tells you the rate of change of the function with respect to an input. And so if I want to know the rate of change of the function h with respect to g's input, I have to find the rate of change of f, the outside part of this function, with respect to g. G is f's input. Okay, so I have to go from f to f's input, which is g, and I have to multiply that by the way that g changes with respect to its input, which is x. Okay? So that means that the derivative of h with respect to x is the derivative of f with respect to g. Okay? That's f with respect to its input, multiplied by the derivative of g with respect to its input, x. Okay? So it's df dg, dg dx. And recall that you can think of each one of these little pieces here, this Leibniz notation, as really a ratio, or that is a fraction of an object. Okay, so it's df dg over dx gg. And if I cancel out the dg's, you can see you get back to dh dx. Okay. Similarly, if I have a function of a composition of three functions, okay, we have a chain of three derivatives, and it keeps going. So you can certainly embed many different functions. There's nothing stopping you at one. And I just wanted to show you that you can define k of x as a function of a, which is a function of b, which is a function of c, which is a function of x. Okay, and it all gets very complicated after a while, but there's nothing stopping you from going to more functions. Okay, and in this case, I know k is a function of a, of which is a function of b, which is a function of c, which is a function of x. And all that happens is, if I want to know how k changes with respect to the innermost input, x, then I have to go through from a to b, then from b to c, and then finally from c to x. Okay, so I have to go from a to b to c to x. All right? And so this is the chain rule. This tells you how the outside function is changing with respect to the innermost input. And it turns out that this kind of function, the composition of functions, has a lot of very important applications.